The first asked control valve question is what is choke flow in control valve? So let us look into that. If we have to understand this concept, we can say that if we have a valve and we keep the upstream pressure is 24 bar, so we keep a constant upstream pressure and the valve opening is kept constant. For example, let's say 50 percentage, and we keep increasing or decreasing the downstream pressure, like example 20 bar, 19 bar, 18 bar, and we try to plot a graph, we'll be getting a linear characteristics. Eventually it could happen that you reach to a point where the pressure difference is not allowing the flow to increase, and this point is called as the del P choked, and this is against the ideal characteristics where the flow should increase, and this phenomenon is called as choke flow. The next most asked question in interview is what is balanced and an unbalanced stream? So let us look into that. Let us take this example of an unbalanced valve. So here's your cage, plug in, seat assembly. The flow is going from the inlet to the outlet. And here you have the force P1 which is acting from the fluid. On the other side there is force P2 from the actuator. Let us understand this amazingly with an example of a seesaw. So here, imagine you have your plug and the seesaw has from one side the pressure which is P1 or the force which is acting from the fluid. On the other side, what is there to balance it? The answer to it is nothing else except the force of the actuator. But let us see a balanced design now. In a balanced design, one of the most amazing thing is this simple hole. What it does is when the flow is flowing, it will also go to the opposite side of it. So here, let's imagine this is the force P1 acting and here this force P2 acting. So if you take the same example of seesaw, on one side is the fluid force acting P1, but on the other side approximately the same force which is P2 is acting on the trim. Now what happens here is actuator has to put very little force in order to move the plug assembly. The third most asked interview question is what are the failure modes in control valve? So without further delay, let's look into that. So in order to understand these failure modes, let us try to dissect each and every failure symbol. So if you see here, for example, FC stands for fail close. So if the flow of air is stopped or there is some electrical issue, the fail close would be the valve's default action. So the valve will get into its closed state. Similarly, FO stands for fail open. So basically in any loss of air or in terms of an electrical issue, the valve is going to go in its open state. Similarly, fail lock. So whatever is its last position, it will stay locked in that position. It will not move. Either if it is in the halfway position, it will remain in the halfway position. This is achieved sometimes via check valve. Now, FLDO stands for fail last drift open. Remember, this is different from fail lock. Why? Because in fail last position, it will just remain wherever it was, and eventually with the help of flow, it will drift to its open position. Similarly, FLDC stands for fail last drift close. Here, the valve is going to remain again in whatever last position when the air supply was cut off, and then it will drift to its closed position eventually. So the flow will try to push it in such a way that it leads the plug into its closed position. The most common type of failure modes that have been used in control valve is either FC or an FO, a fail close valve and a fail open valve. Remember, this information is very important while designing a control valve. So when you find it on PNID, you can maybe mention in the remarks column of the index, etc. But please make sure to capture this information because this is very important for sizing and for understanding a control valve.